world domination plan map over here. 3, 2, 1.
Good afternoon. Hey, welcome to a new chapter of our Beards and Beers. And today with Todd and I, we have a really cool guy. A guy that has been thinking on zeros and one and how the future would look like. With all of you, Scott Livingston. Hey, Scott.
Thanks for having me.
Oh, more than welcome. It's really exciting. Why don't you give us an intro about yourself? What you've been doing for the last couple of years?
So actually around 5 years ago, I finished my PhD working on notions of correctness in software, especially in the context of robotics. And shortly after that, actually, I joined a small self-driving car startup. And I found one of the biggest challenges at that company was around testing and verification of the software itself. And I already had this sense that this was a challenge in the robotics industry from my research before. And so for the past 4 years, I've been working on a company called rerobots that would make robots available in the same style that you can get time on computers and data centers, with a basic principle being separating the software and the hardware through various kinds of contracts. And the practical way that it manifests is through the ability to basically share time on robots with remote users.
Interesting. What kind of tasks do these robots complete for people?
Sure. Actually, it's more of a developer-oriented platform. And so it's not that the robots are performing a task that you would come and then simply have it run the task for you, but you would visit the system that I built or visit the website and then be presented with a Python editor, for example, and write your own code that would run on the robot. But what's special about it, and the reason why you would even want to do this instead of having the robot locally, is I implement various kinds of constraints. So you cannot crash the robot into a wall, for example, but it is a developer-oriented platform.
I had the chance
Sure.
to try his Sandbox, and it's really cool because he provisions an instance in the cloud, and you're going to see it today. If you hit the button down in the registration page, you will be able to see what we are announcing, and you publish and you can come up with an instance that you can control remotely the robot. He talks about Python, but I've seen he has Java and other programming languages. And even he has like different kinds of robots. He has the Kabuki ones that are like the Roomba robots that cleans your house, that you can play around with those. They're camera pointing, and it looks like the future is already here, no? The way you are thinking, and people might think this is a crazy guy, but he's backed by a research. So he's seeing that this can be a new business coming in the next 5-10 years. Huh?
Yeah, well, one of the challenges, so I tried to make the analogy with data centers early on, but one of the challenges with robotics is there's so many different robots as platforms to develop on. And in fact, many companies that are building robots tend not to focus on the robot as a platform per se, but they try to control the full stack. So you'll find companies like DJI are selling a quad rotor that's very tightly integrated from the hardware up to the software. And so part of what I'm doing is trying to predict the future where robots will be more like platforms in the same sense that ARM architecture is a reference architecture that you can develop software on without having to design the chip yourself.
That's really, really cool. What kind of vendors are you using on your experiments when you're building this service?
Yeah, so in terms of the robots themselves, I have a Misty robot made by Misty Robotics. I have several different kinds of robot arms. One is by a company called Haddington Dynamics, a robot arm called Dexter. Actually, it's an open source, open hardware arm that they released the design files for. And also an arm called the Open Manipulator by a company called Robotis. It's also an open source arm, incidentally. But these are larger arms, so they're not just little toys that sit on a desk, but you can pick up several kilograms. And I'm also working with Crazyfly quadrotors and the Kabuki robots that you mentioned. The Kabuki is actually a base platform, so I built it out a little bit. On top of the Kabuki is a Raspberry Pi. I also have Hokuyo LiDAR sensors on board. So the full stack for a single Kabuki with the LiDAR is around several $1,000s worth if you were to buy it off the shelf.
Is there like an SDK that the developers have to get familiar with before they program on this? What's the kind of barrier to entry for a developer? If I came to your platform and I said I wanted to work on, get started with this, how long does it take me from like knowing nothing to being productive?
So I'll clarify something. There's actually not an SDK per se. There is an API to use the infrastructure. So part of what is special that I'm doing compared to other kinds of robot SDKs available that treat robots as a platform is I'm actually building something that's very low level. So the system that I built is not really one where someone learns an SDK for running on the robot itself, but rather they would have to learn an API for provisioning time on the robot, but when they are using the robot itself, they have a very low level access. You can get SSH access and you get root access to a box, and it feels like you have very low level access. And actually what I've built are filters that are right down to the sensor level, right down to the motor controller level. You can develop software in the same way that you would develop software if you actually bought the robot and had it sitting next to you. So the part that does require some special training is around how to provision time on the robots. There is an API for provisioning and getting the access. And again, it's pretty similar in spirit to how someone would use Oracle Cloud. For example, there's an API for provisioning time on an instance and so on. But once you get the SSH credentials, basically you have a root level access to a computer, and it doesn't even feel like you're on the cloud per se.
So I have a last question, and it's how you see the future of robotics in ARM platforms. We have this Ampere service. How you see that filling into the robotic space?
Well, it goes without saying almost that ARM is very well established as an embedded architecture in embedded devices, so devices that are not in the cloud. In fact, the per unit cost is so cheap that often someone would just throw an ARM chip in there in some sense. And so for robotics, that means that ARM is very often what you encounter in the device itself rather than an x86 architecture. So the complement with the cloud side hosting of ARM devices has a lot of potential, both from a building pipeline. So earlier I mentioned automated testing. The real workflow in terms of agile software development is not just automated testing in the cloud, but you also want to build images and deploy them to devices, right? It's the full CI, CD, automated deployment, automated DevOps. And we've not seen much of that in robotics, honestly. There's a lot of progress for CI or automated testing in robotics, but the full deployment from automated testing to building images to shipping is not there in many cases. And I think ARM architectures available in a cloud setting can provide that, because you can build natively, for example, or test on architectures that match what you would have in the robot itself.
I mean, you're in at the ground level of this stuff, right? I mean, this is perfect. To me, it's perfect timing for where the industry's going, for the trends that we've been seeing. I think you're sitting on a gold mine, quite frankly. But we're happy to help spread the word. Anything that kind of brings this cutting edge stuff to developers is stuff that we like to highlight. And so we're glad that you joined us and helped us learn a little bit more about what it is that you do.
I'm really excited to see what the future looks like and hope we can see more from Scott.
Great to meet you, Scott, and best of luck to you, buddy. Take care.
Thank you.